Okay, so hello, welcome to GPC guest edition. It's me, Angie, and today I'm going to talk to you about a couple of things, but mainly I'm going to talk to you about CI/CD for Unity and GitHub and why it's super cool and you should totally use it. Um, so first, the use case for continuous integration and continuous deployment. What it's not for is for really small projects. So if you're doing something that's like super just chill on your own time or whatever, you 100% don't need to set up continuous integration or continuous deployment. You really only want to set this up when you are um, A, when you have time, and B, when you need to save a lot of time. Like there's a lot of benefits to continuous integration, continuous deployment, but basically the kind of time cost to buy into it is something that you need to consider when you're doing your stuff. So what it is good for is quick iteration and testing, automatic building, deploying to multiple platforms at once, and you can make updates to your game very easily with this system. Um, to give a kind of outline of, yeah, next slide of what it is really is it's this idea that you want to continuously integrate your features one by one in your application and deploy them to your users so that you can test them as you're building the game. This is kind of the principle behind early access on Steam, but you don't have to kind of share it with the end user when it comes to games. You can test internally. So one way you're going to want to do that with Unity and GitHub is with this library called Game CI. Um, so it's great because it's free and open source. It's super well documented. It supports unit testing for test-driven development. There's a whole Discord. It only supports Unity right now, which kind of sucks. I want to use it for Unreal because I've been doing some stuff with Unreal lately, but um, Unreal has its own build tool, which is really interesting. But um, for Unity, it works really well. Like it honestly, I just take a while to kind of finish, like mess around with things. But it's a very simple setup, and the tutorial is super easy to follow. And of course, there's also the super fancy stuff that you can do without even uh, I'm not going to go into it here, but um, there's stuff like Docker images that you can mess with and cloud runners if you want to run multiple builds um, on the cloud, and or if you want to self-host, you can run it on your own hardware, and that can lead to some advantages as well as some disadvantages, like having to run the hardware. um, but moving on. The basic steps are to activate your Unity license for the project. You can set up the test runner for your test-driven development unit tests. Then you set up the builder, and then you deploy to your platforms. So um, you can do itch or Steam or desktop. What I recommend is GitHub Pages because it generates a static website for you to put um, your game on. So you deploy to WebGL, and then you get the system to basically deploy GitHub Pages website so that you can basically just say, hey, I have this game I want you to test. Here's a link to a website. And then they can just immediately test it. No download required, which is super awesome. So imagine with the press of one button, every time you push to main or something, or you do like a pull request to main or whatever you want to do, um, it automatically tests and builds and then deploys your Unity game to a website, and then you can go and test that. Anybody can test it anywhere. So they don't have to be like they don't have to have the repo cloned, or they don't have to like merge things or change branches or whatever. This is especially useful for people who aren't very technical on your team. Um, For GitHub Actions, which is the way that Game CI works, it uses the GitHub Actions. Basically, what you need to know about this is that it's kind of like little programs that run on the cloud that do something with your repo's information. Um, so they're kind of defined in a series of steps, and workflows and uh, actions are kind of like little containers of jobs and contain steps and all these things. But when you put it all together, basically you're taking some information from your repo, you're doing some stuff with it, and then you're outputting something new. So yeah, it's basically just a little program. Um, Generally, the environment that they run on is Linux, unless you want to like pay for Windows, which means you can do funky Linux stuff with it, which I do recommend learning that. But yeah, don't be afraid if you've never used Linux before. But yeah, either or other than that, it uses a YAML and a special directory in your repository for you to specify those steps, and I'll show you kind of what that looks like. And you can take advantage of the two biggest features of this, which are the matrices and the library, in order to asynchronously execute the same steps in multiple different scenarios. So let's say I have a job that is defined for building, and I have a matrix that defines all the different platforms that I want to build for. So inside the matrix could be like Windows, 64-bit, Windows 32-bit, WebGL, mobile, or Android, I guess. And then you could do all those things, and then you don't have to like write the build step over and over and over again. You just write the matrix once, and then you apply the matrix property in the appropriate places. One advantage of doing the self-hosted runner for this is that you can make iOS and Mac builds with this stuff, um, which is just yet another headache when it comes to making iOS or Mac games or just applications in general, because you can deploy to pretty much any other platform um, without having to need that specific platform because Linux can build for the web um, and for Windows. And the library is great because you're going to take a tremendously long time, not tremendous, but relatively it's going to be pretty long when you do your first build. So you want to make sure that that data gets cached so that the next time the job is run, then you're going to save a lot of time when you're deploying and building and testing and all that good stuff. So this is an example of what it looks like. And you can see it's pretty easy to read, which is very important. You want your code to be readable. But if I were to um, even just uh, ask you guys what you think some of these things do, and I have the chat open now, so if you want to jump in, go ahead. But um, so this might be self-explanatory to you. You might look at this and say, well, on is it's very simple. It means it's an event trigger. It uses the observer pattern somewhere, or there's like some kind of state machine that listens for when these things happen. And then you can see that jobs is kind of like a list. Um, and inside that list another sublist which has build, and so build is its own job, and it has a name, and it has the environment that it runs on, and then has steps is its own list which has each individual kind of module of functionality, um, and you can see they actually import the kind of modules from this wider library that you have access to, called like the actions marketplace essentially is what it is. um, but yeah, so a job, it has a name. It can be whatever name you want it to be. Um, the actual name field is just what's going to show up on the GUI when it looks pretty. But yeah, it'll execute those steps, and then once it's all done, it'll move on to uh, the next job. Um, if you tell it to, because a lot of the stuff is done asynchronously. But just to go over some of what's going on here. Um, in order, you need to kind of think of this Linux machine as a blank slate. It doesn't know anything about your repo or your game or anything, so you need to tell it some information and tell it how to use that information. Um, so one the first way you're going to do that is you're going to check out the repository because this new Linux slate every single time is going to be different. So it's going to take the repository, so that way it has the data, and then it's going to make sure to use the cache that is included in the repository for your tests or your build. And then after that, you're going to use the game CI modules to basically do the magic for you, the work really. Um, and so here's a notion here of these secrets. Um, I'll get into this in a bit, but essentially what it is, it's just a bit of sensitive information that you need other people to have access to without them knowing what it is. Um, and you can already see that that's a lot of words. Like I said so many words there that at least while I was in the program, we probably would have never really learned about. So while keeping all this stuff in mind for game CI, and I again highly recommend all these. I recommend all the things that I've said so far. Check out game CI. Make make an effort to explore those things that you otherwise wouldn't have touched. Um, we also have to understand that because our educational is not a kind of like traditional approach and our industry is not very traditional, there are a lot of words that don't make sense, or maybe they do make sense and they just mean they mean the same thing as something that we would call something else. So some examples of that could be like a blackboard for a behavior tree, if you know what that is. A behavior tree is basically just something that's used to determine the behavior of an AI. What a blackboard is it's a basically global in respect to maybe other entities or all the entities of one certain type. Um, it is kind of like a key value list of okay, what does the position of the player look like? So maybe the key is player position, and the value is some vector. Um, that's a database, basically. That's a key value pair database. Um, so when I started figuring these things out, I realized that I need to go out and learn about all these different things because in especially in like your early game development career, you're not going to hear about these things, and they're super useful. Also, for the comments, we aren't really software engineers. You absolutely are software engineers. Um, I would say actually that you do a lot more engineering than you probably have to because of what I'm talking about here, this kind of phenomenon of we don't really have the same terminology as the other tech industries. Um, and I like my cursor trail, so I turned it on. I'm not sorry. But anyway, so to go through some of these terms, CI/CD, continuous integration, continuous deployment. We just talked about that. YAML, I don't really know what it stands for, but what it really is, it's a markdown language, which a markdown language is just something that's used for like very simple instructional. Um, can either be like programming or formatting, or for example, your commits on GitHub are written in Markdown, or you can actually write Markdown in Discord. I believe its formatting is literally Markdown. Docker is something like the jargon for it is like it containerizes applications to decouple them from the platforms on which they're going to run, which really what that means is it allows you to test your applications on multiple platforms. Um, so without really necessarily worrying about like what the platform specifics are. It doesn't solve all the cross-platform issues, but um, actions for GitHub Actions and all these like different terms, like all these libraries have their own terms. Um, and Unreal is especially bad for this. If you've ever played around with Unreal, it's not a player, it's not an entity, it's an actor, or it's not a script, it's a blueprint, or it's not a world or a scene, it's a level, which is, you know. Um, just kind of ridiculous. But so yeah, static site generator, that's what I'm when I'm talking about GitHub pages, I'm talking about the tool Jekyll, which uses Ruby to basically bundle together a website into a static content bundle that you can include a Unity game on because Unity games can resolve to WebGL, which you can display in the browser. Um, so for that much, uh, it's not too hard to set up, but you do need to do some research into what is it like to make a static website with Jekyll, or what is it like to work with something like GitHub Pages, and then secrets we talked about. And there might be other things that you guys might think of off the top of your head if you've dabbled in other areas of tech at all, even just for fun, where uh, you might say like in React for web development, it's a framework where you can define components to represent UI and functionality in one, and that goes on the component tree. And that kind of, it sounds awfully like some kind of like game object or like entity component system that you put in the hierarchy so that that can be displayed in the world. Um, and so once you start drawing those lines, you can really kind of pull from the different resources from both spheres. And so I'm going to get into a couple of things that I have learned from app and web development. Um, Now, full disclosure, I don't do it for a living or anything. I was just like kind of dabbling around because I was curious, and a friend of mine is super into web development. Um, but here are some things that I've learned. So, database, there's web development buzzwords like uh, all sorts of things, like blazingly fast if you want to sound stupid, or like game changing, cutting edge. Or just like the speed at which they are able to create JavaScript frameworks. It's like there's a new one every single week, and it's like I don't know how web developers keep themselves sane. But one thing that I really learned from web development actually that isn't listed here is like package managers and kind of how they work. So NuGet package manager for C Sharp, or there's also NPM for JavaScript, and I believe some other languages too. They allow you to kind of add dependencies to your project without having to go through this like, oh my God, I gotta like download the library, I gotta statically link it to my solution, I gotta like put the DLL in the same directory as the executable. Like you don't have to worry about any of that. You just say, I want this library, yoink, and it's as simple as that. And we could really use things like that for Unity. And one example of a kind of package manager for Unity is called OpenUPM, which is Open Unity Package Manager. It's an open source project, and there's a lot of good stuff on there. Um, JSON, if you've never interacted with it, you probably have at some point and just don't know, but it's really great for what's called serializing and deserializing your data for constructing classes and deconstructing classes into writable objects. So that's good for saving, that's good for networks, or networking rather, and it's good for loading, or if you just need to kind of communicate information from one place to another place without having the code be coupled together. Which brings me to MVVM. That stands for Model View View Model. What does that mean? In this case, we're talking about a data model essentially. So model refers to like I have a person. A person has an age and I don't know, a job or something like that. Um, and that they usually only contain data members. They don't contain really any functions. And that model is what is basically your data. Um, that's going to get serialized to disk, for example. You could use that to be your save data, a class that represents your save data. The view is going to be how the user interacts with what you're talking about. So model can also be used in the sense of a um, a script that you use to kind of manipulate what your UI looks like in Unity or what the game world might look like. So if I have a model for a person, my person model I could also have a person view, which would be the actual UI that we construct in the editor. And the view pulls information from the view model. The view model, which is the VM part of this, takes information from the model and it might like manipulate it somehow. Um, or like this is really where your scripting gets in, where you like say like, oh, I want this value to change based on this, or like this animation curve I'm going to plug in, or a reference to this thing. Um, that view model is going to feed the information to the view, and the view is ultimately going to be what the thing is, what the user ultimately sees at the end. So yeah, it's a very long-winded way to say that you want to separate your data from your UI concerns or your basically end user concerns. In our case, for game development, if you're doing front-end gameplay stuff, then you could realistically call that like not UI related things. You could call it like your enemies, or you can call it your mechanics. How do you want to separate the data of your mechanics from your actual implementation specific details? And this is great because it opens the door to saving and loading very efficiently because you can very quickly just reconstruct a class. So you can save something to like the player prefs in Unity, or you can save it to disk or something. Um, but anyways, I talked about that enough. It's like my favorite design pattern right now. Test-driven development, or TDD. This is an idea where you start. You don't actually write your code at first. You write a test for your code to test to see if it's working. Um, and you write it at first so that it fails. And the reason why it fails is because you haven't implemented the code. But basically, the framework is you design your software, you set up your test, and then you try and implement the code until it passes the test. Now, when it comes to games, it can be a little bit impractical to do this. And the reason why is because we often work with weird, extraneous scenarios where things aren't going to be the same every time because of the emergent nature of most games. But there are tools out there to actually test your games in a way that is meaningful and automatic. And so I don't remember exactly like what the name of it is, but there is one specifically for Unity. And so somebody used it to test like this one glitch that happened like once every like million iterations or whatever, or like a really common bugs, and it's just automated testing, so it's like running around as the player doing something, and these are actions that you can record in the tool, and that's really fun. That's really cool because it allows you to do a lot of bug testing at once. And then the last kind of thing here that I wanted to mention, besides the principles on the right, I'm not going to go through those, but those are the principles of information architecture. But tech stacks, that doesn't make any sense as a word. When you just kind of think of it, it's like, what is a stack? What is a tech stack? So a tech stack is basically you have um, kind of these layers of APIs or frameworks or libraries or functionality that kind of build on top of each other to create an application. So you might have heard of the term full stack developer, or front end developer, or back end developer. Front end, actually, we'll start with back end. So back end refers to things like database or more data-driven things, creating tools for the front end developers to use to create the final content. Um, so that would be like a technical artist, or a like an engine developer, or somebody who's making tools specifically, a tools developer. Um, and then your front end would be like front end gameplay, or writing up all the UI, or setting up those kind of really on the nose like user interactions. So the reason why we call it a stack is because usually when it comes to web development and app development, you have loads of different things that you can kind of choose from to kind of replace in the stack. So maybe you want to use something like um, I don't know, you want to use something for a database, so you use like MySQL. So that's part of your tech stack now. And then you want to use something else for your front end, so you're going to use React, and that's part of your front end now. For us, we don't really think about that. And I think it's important to think about that. But for us, our kind of tech stack really is we have, in our case for this presentation, Unity is our tool. Unity is our tech stack. And we might have external tools if we try and do something creative, but we're so kind of tied to these tools that we have because they're so in depth. And it's good that they're in depth, but it also kind of detracts from this idea of the tech stack because it kind of limits our creativity in the way that we use our libraries. So Unity handles like all like file IO or like all this front end gameplay stuff and scripting and like interop between languages. And um, what it doesn't handle is networking. So, okay, what are we going to do for the networking portion of our tech stack? Are we going to write a library for it, or are we going to search somewhere else to fill that kind of spot in our tech stack? Or are we going to pull packages from OpenUPM for a certain part of our project? Or do I need some access to like a database? Am I writing an RPG and do I need to export some spreadsheet from Google Sheets to um, then uh, export it to like JSON or SQL or something so that I can import it to the game so that I don't have to manually, you know, pull all of these objects one by one into my game. There's all sorts of automation and things that you can do here, and that's kind of the final goal of what you're doing here. You want to make it as easy as possible to essentially write your game um, when it comes to coding, and you want to enable yourself and other developers and designers to do the best work that they can. Um, so for some other helpful tips, like I just said, make apps and tools for your team. They can be for your own productivity, so it could be something for fun that you want to do to explore this kind of side of things. Um, but for me, what I was doing was tracking. For example, how many hours of sleep I got a night was something like really simple. I wanted to track and like I wanted to store it on a database, be able to read it back and like graph it because I'm a nerd. And so I did that. I made an application in Windows, or I think it was WinUI 3, yes, which used C Sharp, and it was completely like removed from games or anything. Like it had nothing to do with Unity or anything. But I learned a lot. I learned model view model from that one, and a lot of other things too, like abstracting away. Um, Functionality with interfaces in particular is a very interesting one, or calling them services and contracts, which is a very weird um, kind of way to phrase it, but it's just a different way to say compositional inheritance or just inheritance in general. Uh, Getting rid of your duplicate code, that's kind of the goal. Um, so that was a kind of interesting thing for me to do, and it also gave me insight on my sleep. And I didn't have to worry about anybody stealing my data or, knowing how much I sleep at night because I wrote it. So that's cool. Um, Another thing is that this will help you stop reinventing the wheel because you'll start to realize that there are a lot of things out there that do what you're trying to do without you having to reinvent some kind of crazy computer science concept. Like recently at work, I was trying to render a list of I was trying to render a tree of nodes, which is like a huge problem in computer science that you might have learned about. But I didn't realize that, I needed to do specifically what I needed to do, which I can't say. But, I was looking into it and I was realizing like I am approaching this problem in the sense where I'm trying to reinvent or like create this whole new paradigm to look at this problem when I could, instead of doing that, um, just either find something else that does it for me or just make it easier on myself by leveraging the tools that I have. One thing that we really do have that our industry has pushed forwards besides just graphics and animation is the use of the editor. Because in web development, app development, you don't really have an editor, at least in some frameworks. Some frameworks they do have an editor for more specifically like desktop apps, but for web apps, it's generally not really used as much as just writing an app from scratch. And what the editor allows you to do is it allows you to take your focus away from the specifics of how the view of something is going to look when you're writing your code. It's not going to be programmatic and beautiful and like perfectly spaced. It doesn't need to be. It's an emergent game, right? There are things about it that are going to be different, and sometimes you need that. So leverage those things about the game engine that you're using, and turn those problems from huge things into smaller problems, or find a library. There's no shame in it. Um, if anything, try and learn from what the library is doing. Um, Communicate more effectively with designers because you can kind of point them to examples of what you're thinking of. Build your portfolio site or your studio site or something. So this could be with GitHub Pages, or you could try and learn JavaScript and React, or learn all the million other JavaScript frameworks that are out there. Um, and you can learn so much from doing like all these things. You can be um, really creative with it, and there are so many good um, people out there that are willing to kind of teach you uh, what other spheres of tech are like. And I highly recommend networking with people in the games industry. But I also highly recommend talking to people who are completely removed from your development experience. And the like besides all this, the points I've summarized so far, it's more so just that they have insight on problems that you haven't had to solve before. So they are ultimately going to know different things. And when you exchange that knowledge, there's a lot of these little things that you can start to pick up on. Um, there's a huge reason why games is an interdisciplinary field, um, besides the fact that it needs to be for a multitude of reasons, but it's because all these people train like electrical engineering, or they're in software engineering, or they're in user experience design or UI design, and they come from all these different places and they come together to make something that is greater than the sum of its parts. Um, and that's great because you can learn from so many different types of people. Uh, and so the only kind of dangerous thing about keeping yourself in the sphere of other specifically game developers or game makers is sometimes you can kind of starve yourself of that extra information. Um, you're not always going to have people who haven't like a degree in software engineering or experience working on something crazy or whatever. It might be interesting, or you might still find interesting people that you can learn from in the games community, though. But um, definitely uh, just go out there, network with people in the games industry, network with everybody you can who knows how to program, because they will teach you something, and you can probably teach them too. Um, all that to say, I know this talk was about like two seemingly unrelated topics, but I just wanted to showcase how kind of big the journey is ahead of everybody, including myself, when it comes to being a software developer, whether that be for games or not. There is always something to learn. There's always new words or frameworks or libraries or concepts, always new design patterns, new people to talk to. And it's important that even after you graduate or even on your downtime, you either are practicing your skills or you're trying to learn from somebody to some extent. You can really think of this stuff as an art form because of the fact that it needs to kind of be practiced um, in a long period of time to get into your long-term memory so that you can actually become good at it. Um, So I hope that you can implement game CI for your games at least for next semester, um, because I honestly it's super cool to do, and also there's a lot of benefits to it. You can just send somebody a link and they can play your game, and it's super fun to be able to just like push a button and then wow, my update is on itch, and then everybody who wants to play my game has my update. And I also hope you learned some stuff about being a developer from my perspective. And yeah, thanks so much for coming. I guess we can take any questions if we have some. We do love a little game called Mario. If you don't know about that, it is a an open source game project written in Godot, um, and its whole premise is that anybody can contribute as long as they approve the pull request. It's open source, so it's another one of these things where like in games, open source seems kind of alien to us almost because it's so weird to kind of share your code. Um, but in the wider kind of tech world, it's the norm. Most software is actually open source. Most software that gets used anyway. So it's an open source game that anybody can contribute to, and they will add your name to the credits. I have actually contributed to a little game called Mario. I think I was in the middle of making it like a much bigger contribution for like fixing a whole game mode, but I kind of got distracted and sidetracked. But my contribution was fixing some physics thing because something was backwards or like even something small like that. Um, yeah, well, I'm not. I think it uses game CI, but it also uses some other fancy stuff called like Butler for specifically updating and optimizing the updating of HIO games that exist on WebGL, I think. Although I think it works for other platforms too. Um, but just to give you an idea of all of this too, like when you go onto GitHub and you see um, a repo, like you just find any random repo that isn't like a super low level like C or C++ thing or like a game, and you'll see there's like 10 different languages going on, right? There's like so much going on. It's like, what's happening? Why are all these different languages? It's because there's so many different tools to do these things, right? And it's kind of unfortunate in games that we don't really get to our dabble around in different languages that often. Um, so that's just another one for you there. It's a freebie, I suppose. Do you have any other questions? All right, I guess we're good to go then. So thanks for so much. Oh, I can't speak. I ran out of speaking. Thanks so much for coming. I hope you learned something. Good luck with the rest of the semester. And yeah, have a good evening or night, I guess.
Thank you so much, Angie. Can we get a round of reaction applauses?
I'm on my phone, but you did amazing.
Clapping for myself.
Woo! I could turn on my webcam now, so. Wait, did you stop recording?